So lesson 7 is moving into, oh, welcome back, I forget. Lesson 7 is moving into scientific notation. We want to be consistent in science, so we use exponential notations for very big and very small numbers, but there are specific rules. And basically, to create scientific notation, you start by counting the digits left or right from the decimal point. And the number of digits counted becomes your exponent with a base of 10. If you count left, the exponent is positive. If you count right, the exponent is negative. And then the one rule I didn't write down is you always have one digit and then your decimal point. So that 25 trillion, so instead of writing 25 times 10 to the 12th power, you would have written that as 2.5 times 10 to the 13th power, because from the decimal point, there's 13 spots to get to the decimal point till you move that decimal point right in front, next to the 2. And just like the other one with the small number, there was 4 spots until we got to the 6. So we have one digit next to the decimal point, and then that tells us how far we went and what exponent to use. Okay. All right. Playing with magnitude. So let's say we have this huge number, 993,456,789,098,765. Find the smallest power of 10 that will exceed or be larger than m. Okay, so think of that. So 10 times 10 times 10 times 10 times 10, right? So if I multiply by 10, there's the first one. By 10, second one. By 10, the third one. By 10, the fourth one. By 10, by 10, by 10, by 10, by 10. How many times am I multiplying by 10? I'm adding one more spot. Okay? So basically, if I count up my spots till I get past 993. Okay? So powers of 10, 10 times 1 is 1. 10 to the power of 1 is 1. 10 to the power of 10 to the power of 0 is 1. 10 to the power of 1 is 10, right? So to get bigger than the 5, I have to get a 10 to the power of 1. To get bigger than the 6, I have to get 10 to the power of 2. To get bigger than the 700, I got to do 10 to the power of 3. To get bigger than the 8,000, I've got to do 10 to the power of 4. So how many until I get larger than this number? Okay. You're going to have to answer that one on your own, I guess. Maybe I'll ask it as a question. All right, more fun with magnitude. So if I have 78,491 and 899,997, so that's a big mixed number. What's the smallest power of 10 that will exceed or get bigger than this number? So basically, I'm looking 78,492, right? So I've got my powers of 10. So power of 10 to the power of 1 would be bigger than this. 10 to the power of 2 would be bigger than this one. 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, right? So 78,492 is bigger than 78,491. And then 10 to the power of how many? Okay. Magnitude of small numbers. The chance of you having the same DNA as another person other than an identical twin is approximately 1 in 10 trillion. 1 trillion is 1 followed by 12 zeros. Given the fraction, express this very small number using a negative power of 10, right? So 1 in 10 trillion is 1 over 10 trillion with 12 zeros there. There's a 10 with 12 zeros. So now 1/10 is 10 to the power of negative 1. 1/100th is 10 to the power of negative 2. 1/1000th is 10 to the power of negative 3. 1/10,000th is 10 to the power of negative 4. How many zeros, how many negative exponents until I get bigger than 10 trillion or equal to 10 trillion? Think. Okay. All right, we will take a look at this in a minute.